Okay, so let's see. Did we go through the slides last class about what I think might be on the exam?
No.
All right, so we shouldn't do that.
That would be more.
It'd be helpful.
Yeah.
That's what you're saying.
Yes.
All right. For starters, I think I posted it on Slack. I went ahead and actually I already have the exam written, so you're getting a benefit here because I'll like have it fresh in my mind whether or not I actually put it on the exam, and then I'll lie to you. So, but the exam's already written. I have it set to release during class time on Friday, so 2 days from today. So you don't have to come to this room to take it. Just go to a computer where you have access to Blackboard, whatever. So the exam will be available from, I think I have it set up to be available at 11 until noon, so you get 5 extra minutes on either side. Same exam I would have given in class, 10 questions, blah, blah, blah. At the end of that 1 hour, you have to take the whole thing during that 1 hour period. Then it'll submit. That way I can get it graded sooner rather than later, since I'm going to be out of town. Otherwise, I'll have a stack of papers sitting here and won't be able to grade it while I'm gone.
Okay.
Yep.
So you said it's only giving 10 questions.
Yep. Yeah, and then for those of you who are taking them like in the testing center and stuff, it's adjusted for time and all that stuff. So you'll get your accommodations and that kind of stuff. Okay, so let's go through these slides so I can tell you what might be on the exam. But everybody's clear. You can come and sit in class if you want with your laptops. I don't care. Just don't cheat off your neighbor. But, there won't be a physical exam handed to you on Friday. Instead, it's up on Blackboard, but you won't see it yet. You'll see it starting at 11 a.m. Friday. Got it? So set your alarm. Make sure you get up in time and don't miss the digital exam. All right, so let's go through this. I'll kind of give you an idea on, quote, what I think will make the exam. I might be vague in a couple of areas because I happen to know what's on the exam now. But I'll tell you what I think is important material and what is less important to be tested on. One kind of general statement I'll say, and this goes for all of my classes, I cover a lot of material that are kind of applied to the bigger idea of computer science in most of my classes. With that in mind, whenever you're taking an exam in one of my classes, think about what that specific class is about. All right, because I might cover a topic in this class, like for instance, we talked about the cost of memory back in 1996 and stuff like that. And we talked about these things as being, they're important to the larger idea of computer science. They also gave us some context for why older programming languages were built a certain way with so many different ways of holding integers and stuff like that. So this is important knowledge to have as a computer scientist. But when I give an exam in this class, I'm really testing your problem solving, computer programming knowledge. Okay, so the exams are going to certainly be very, very heavy on those types of questions rather than, let's call it important, but more kind of trivia type knowledge. Knowledge that actually might benefit you, like at the CS get-together tomorrow. So tomorrow from, what was it 11:30 to 1:30, or 11:30 to 1, I think is the thing. Over in the computer science department, we have free pizza and stuff like that. CS get-together. Make sure, how many of you have never been to one of those before? Okay, definitely show up because there's good prizes. So Dr. Locklear posted, oh, fabulous prizes, whatever, blah, blah, blah. Show up right at the beginning because we do this little meet and greet game where, you have to go around and get a signature for somebody who has the same shoe size as you and that kind of stupid stuff. It's just like to get to know your other classmates because, many of you might know each other, but you don't know some of the upperclassmen, and maybe you'll even meet someone who's in one of the upper division programming classes who can maybe help you with some of the homework and stuff like that in here. But if you get first or second place in that thing, you get first dibs at the best prizes. And best prizes this year, I think we have an Oculus Go VR headset. There's usually an iPad of some sort. Sometimes there's a laptop or a Chromebook, usually a gaming monitor. Good stuff, not like crap. But after you get past those first couple prizes, then things start, you get down to like Chuck Norris DVDs and stuff like that. So things start getting sketched pretty quick. But in any case, it's a good event. If you can make it, show up tomorrow. We like to have a good turnout, and you get free lunch and stuff. So save a swipe or donate a swipe to me, whatever makes you happy. Yeah, I collect swipes. So if you're ever looking for a bribe, that's fat people like lunch. It's a thing. All right. So questions about that thing tomorrow?
No.
The CS get together thing. We're all cool on that. So definitely show up. I'll be there, and I'll have my Superman cape on and stuff. So it'll be actually that's my cape right there in the back. I keep it in my What's up?
Yesterday you posted something on Slack that said, "Remind me in class tomorrow, but I had to tune out.
Oh, yeah. Thank you. Yeah, so I told you that I won't be back for the Monday after break. I actually will be. So you know how like midnight looks like it's the day before or the day out? Yeah, so I'm going to be back like at like midnight on, like 12:05 a.m. on Monday, but before class, technically. I had read it the other way. So I will be here the Monday after break. We will have class, but if you had already modified your travel plans, I won't give a quiz or anything that day, so just watch the video or something. Okay? So I encourage you to show up to class, but I also had already told you we wouldn't have it, so if you did spend an extra day at home with your parents or away or something, that's fine. Don't change your plans now, just watch the video. Everybody cool with that? All right, but I will be here the Monday after break, unless my flight gets delayed by many hours and that kind of stuff. Okay, so let's go through these slides, and I'll point out what I think is important to study for the exam. The exam will be 10 questions. Each question is worth the same number of points, 10 points. They're all short answer essay, write a little piece of, write some code that does something. No true false, no multiple choice. I never do those kinds of questions. So something like this, what's computer programming? Fair game for the test, but this I would have to be like kind of desperate for a throwaway question. So I would expect you to be able to give me some sort of answer that gives me a rough idea that you know what computer programming is at this point in time. So I wouldn't spend tons of time figuring this out. Let's see. Protocols, I kind of threw it out there as just this. This is more of one of those computer science terms that when we think about languages, it's actually a protocol. So whenever you're specifically like in a networking class or something like that, and they're talking about like the Ethernet protocol, that's no different than the Python protocol, where we're speaking to a computer using Python. Probably won't ask a question about that kind of stuff. You should know why programming is hard, but not something I'd probably ask specifically about. This would be fair game. I refer back to this pretty often, this idea of, how do human beings solve problems and how do our programming languages provide facilities for these things, right? Pretty important concept and kind of at the heart of how I teach programming. Job of a programming language, fair game, but I would expect you can come up with some sort of blurb of stuff that isn't horrifically wrong, so I probably wouldn't ask that kind of question. Be familiar with binary zeros and ones. There will be at least one conversion question on the exam. In fact, you will have at least one conversion question on every exam you ever have with me in any class. All right, that should be free points, but be able to convert from one base to another base. Be able to convert from, kilobits to gigabytes, those types of things. That's knowledge that all computer scientists should have. You should be comfortable with those kinds of values. Okay. So certainly this whole idea, the mapping between how do human beings solve problems and what do the facilities languages give us, important concept that will be on the exam in some form. This is fair game, but I'm probably going to focus more on the specifics of what we're looking at in this class. So in here, we're working with Python, high-level language. So this is important knowledge to know in the big scheme of programming, but not necessarily something I'm likely to test you on an exam. All right. The concept of a CPU is a collection of magic tricks, kind of similar to that idea. Probably not something I'm testing you on in this class, but something you will be tested on in another class. But I wanted you to understand kind of the concept of where all this stuff is connected in the world of computer science. This guy's maybe more fair game given the fact that Python is an interpreted language. I want you to know what that means. For Python to be an interpreted language, we've mentioned that means it's kind of relatively slow because it's going through a translator before it actually gets run on the computer. This is related to the last slide, the idea of an interpreter, like we've been using the Python interpreter. So something related to this would be fair game about, because it's specifically about Python being an interpreted language, requiring the Python interpreter to work, that kind of stuff. Probably won't ask you something specific about compilers. It's the alternative to interpreted languages, the alternative to an interpreter. So this translates our code into zeros and ones prior to us running it. So I'd call this real low priority. And this is related to the last couple slides, so same ballpark. Probably wouldn't ask you about the use of assembly today. You know, that's kind of more of understanding the various levels at which our computer understands things, and we don't really like writing stuff in assembly, but there must be a use for it at some level. That would be something that would be more in like the computer organization and architecture class that we talk about in a lot more detail. So probably not going to be tested on that. Nothing from this. Knowing the difference between a procedural and an object-oriented language, probably important. Much more important, I would think. I mean, the book has already introduced you to the concept of objects, but I haven't covered it in class yet. And that would be another caveat I throw out there. I won't test you on stuff that you write in the book that we haven't covered in class. That doesn't mean it's not important. Okay, it kind of fills in the little gaps because we only have so much time in class to cover things, so I'm kind of hitting the highlights, and then during your homework, you're maybe filling in some of those gaps with things you learned from the book. But I'm not going to ask you some obscure question that you read in some paragraph in the book that I never talked about in class. Make sense? I'm testing. When I present something in class, it's probably because I think it's extra important. So that I want to make sure you hear it at worst twice. So those are the things I'm focusing on when I ask questions. That isn't to say you shouldn't go back and review the chapters from the book and maybe go through some of the exercises that have you practice some of the stuff we've also covered in class. That would be good practice, but you don't have to stress about me asking some weird thing that we never talked about in class that just happened to be in one sentence in some chapter in the book. All right, I'm not going to do that. So having said that, you've already read about objects in the book, but we haven't talked about it in class. So you could expect I'll definitely test you over object-oriented stuff on the final exam, because we'll definitely be covering that. I won't ask about it on the midterm. We haven't discussed it in class. All right. You should know the difference between loosely typed and strongly typed languages, specifically because Python is loosely typed and does not require us to label the kind of value a variable is built for holding. So that would be fair game for a type of question I could ask. Certainly, you should know where Python fits in the world. So if I ask you what kind of language Python is, it's a high-level, object-oriented, loosely typed, general-purpose interpreted programming language. I don't know if I'd ask you to like list all 5. I might ask you, what does it mean for Python to be a loosely typed interpreted language, that kind of thing. To kind of highlight those couple of things that are really meaningful to us. General purpose is, hey, just solves all sorts of kinds of problems. Object-oriented, right now we're just using Python as a procedural language, even though it's an object-oriented programming language. We haven't started building objects yet. The idea of it being high level, yeah, I mean, that's important, but all the languages that as humans we choose to code in are going to be high level languages unless somebody's forcing us to do something like at a low level language. But most of our languages would be high level. But you should know where Python fits in the world of languages. All right, so this kind of goes with that mapping thing. We represent our memory through variables. You should definitely be comfortable with defining variables, putting stuff into them, understanding that variables resolve to their most local definition, understanding in code when you have a variable and your code is running, that variable will turn into its value. So its value is the actual thing that it will ultimately become, and that's what you're operating on. So be comfortable with variables. You should be able to write them, you should be able to read them, all that jazz. Primitive types are important, but this is more of a computer science big picture thing. So I talked about this a few minutes ago. The idea of like byte short, int long. That doesn't mean much to us with Python, given that Python is loosely typed. We understand that under the hood, Python's probably attaching a type. If we hold the number 5, it's treating that as an integer type. If it's holding the value hello, it's treating that as a string type. And we've seen that kind of stuff at work when we've like messed with concatenation, right? Where you have to have 2 strings to do the concatenation thing. Otherwise, you have to convert one of the dudes to string. All right, so we know types exist in Python, but Python makes types kind of hidden because it's a loosely typed language. So this is important computer science knowledge, but not something I'd specifically ask about on the exam. All right, you're going to see these things next semester when we do Java, and Java is a strongly typed language, so we will be defining the kinds of variables that we have each time. So I won't ask you anything specifically about this. Maybe fair game would be primitive. I wouldn't even say that. I'm not going to use the term primitive types, but I'll just say out loud right now, primitive types is a across-the-board computer programming concept where it's kind of our most simplified variable type that can only hold a value. That's what primitive types can do. Like an integer can only hold a value. A char can only hold a value. A string is an object type. It can hold a value, but potentially do more. And we've seen that recently with the find function, right? Where we had a string and we had that string call his own find function to find something in there. So strings can do more than just hold a value. So a string would not be a primitive type. Okay, but I won't ask about them specifically on the exam. Same thing, memory cost. From a computer science perspective, we want to appreciate it. Used to be really, really, really expensive. Now it's really, really, really cheap, and that's good for us. But our languages today are based off of much, much older languages, so there's some leftovers there. We're starting to see a change in technology that's moving more towards speed and redundancy rather than or moving towards speed rather than being afraid of having the same data duplicated too many times. But that's not something we care about in here. But it's something we care about as computer scientists. All right, so nothing about memory cost. Definitely conversions. Like I said, you'll have at least one conversion question on every exam you ever have with me in any class. It doesn't even matter if the class was basket weaving, you'd have a conversion question. I won't ask something specific about internet speed, but we use that as an example for data conversion. You know, if your internet is 20 megabits per second, how fast can you actually download stuff in kilobytes per second, that conversion stuff. So I won't ask questions related specifically to internet speed. It'll be more like, here's a value in gigabits. What's its equivalent in kilobytes? That kind of thing. So another conversion thing. So that's what these guys are all about. So all the conversion, binary, blah, blah, blah stuff. You should certainly be familiar with the kind of our common computer science bases: binary, octal, decimal, hex. Hex is base 16, in case I use those by name. But conversion, you should be able to convert for any base. If I say convert this hexadecimal number into base 4, that's fair game. Okay, you should be able to work with any bases either direction. Know both patterns. This is more trivia type stuff. Important, but you know, in Python, actually integers can be represented much larger than that. That's why Python is used for a lot of data science, neural network type stuff, because values can get really, really large. But I won't ask something specifically about this. This is just more about most integers are 32 bits. You won't have to memorize things like this, you know, that you should know the difference between a signed and an unsigned value, where a signed value can hold a positive or negative, and an unsigned can only hold positive values. I would call it relatively low priority. It might make it onto the exam in some form. You should understand that concept, but I'm not going to ask you, like, what's the largest value that can fit inside of a 16-bit signed variable. Okay, that would be 32,767. Would be the, so you should memorize, no. So you don't have to memorize those. It's plus or minus 2 to the 15th power is what it actually comes out to be. But you don't need to know those numbers by heart or anything like that. But understand that from a computer science perspective, when we have 8 bits to represent a number, that represents smaller numbers than if we had 16 bits to represent a number. That kind of stuff. History of languages, again, this is important trivia stuff. I won't ask you to like draw this chart or anything like that. Really, just in the back of your head, I want you to just kind of know that all of our modern languages come from C. Really, we can say all of our modern object-oriented languages come from C++. And we know that Python, this guy over here, is an object-oriented language. So at some level, it is influenced by C++, but that doesn't directly impact us in this class. All right, so I'm not going to ask you questions about, you know, what features C had, what features C++ had in Java as we kind of went through this guy. These are important, and you should know these things from a computer science perspective. So at some level, this is knowledge that you do want to be comfortable with. But in terms of what I want to test you over, because at the end of the semester, I have to give you a grade based on how well you've mastered the material of this class, because I'm going to see you next semester in 250, and whether you have memorized the history of the structures that are in C or not, that's not going to directly influence your success in 250, but your ability to write software and work with Python specifically and stuff like that will. So I'm testing you on those things. All right, so you could probably skate by without ever learning this stuff, but at some point in the future, you might have to be a C programmer, which is a good language, still used pretty commonly, actually, where these things are going to be fairly important that you know this, but I won't test you on it. Same thing, all these slides that deal with, like, you know, what the languages had, what they lost, what they brought back. Uses of Python, probably won't ask a question about it. It's important for us from the perspective of, hey, why am I learning this language? But not something I'm going to necessarily test you on. Certainly, you should know what a Boolean expression is. Any expression that boils down to a single value of true or false. And that we use Boolean expressions in our conditionals as well as in our loops when we deal with while loops. Most of the loops we've written up to this point have been for loops, where we use that little range function. So we're actually not using a Boolean expression in there, even though one is involved. We're just not directly writing it. But certainly we heavily use Boolean expressions whenever we ask a question. And if we're writing a while loop, we also use Boolean expressions. So definitely know what those guys are. Definitely be able to write those, because I expect you to be able to ask questions on the exam with an if statement. I expect you to be able to write loops. I expect you to be able to print stuff out to the screen. You should be able to do the math operator type stuff, add, subtract, multiply, divide, integer division, the double slash. You should know that, dude. Modulus, the percent symbol, for getting the remainder of an integer division. You should know that, dude. Trying to think anything else that's like just, you know, anything we've covered in class basically. So strings, be comfortable with them. But I want you to be able to write basic logic. If I ask you to write some Python code, properly indent it. It's required for Python, it'll be required on the exam. Go ahead.
How long are those questions you make, the actual coding one? Can they be like as long as the homework assignments? Or?
Yeah, so there'll be like 5 programming questions on there, and every single one of them will be at least the length of the hardest programming question for homework. No, much smaller. So little, I mean, it might still intimidate you on the exam, but much smaller types of problems. Yeah, much smaller types of problems. Also remember, my policy is if you do better on the final exam than you do in the midterm, I'll replace your midterm exam score with what you get in the final. So even if you walk in and you get a 0 in this exam, you can still get an A in the class. Just figure out why you suck now and improve later. Right? Make sense? Go ahead.
When you're like doing the programming questions, are you actually like writing it in Atom and then like copy pasting your code, or like are you just typing it freehand?
Well, like if you're writing it, like when you're doing the exam,
Yeah.
it's up to you. You could write it in Atom if you want, because that'll help you with the indentation. I probably don't want you to run the program to make sure it works before you type it in there. I want you to give me your best. I mean, I'm going to grade it as if you wrote it by hand. So I'm going to be lenient on, you know, a missing colon here and that kind of stuff. So if you write in Atom, it might benefit you to, you know, to have the indentation in there. That's fine. If you're comfortable with that and then pasting it in, I'm fine with that. Otherwise, you can write it directly. Yeah, I mean, just use your own judgment. If what you think you're doing is cheating, it probably is. If you think it's a reasonable thing to do, that's fine. I mean, you'll find out when you get to industry. Nobody wants to get a computer science degree and then go out and get a job and get fired because you don't know what you're doing, right? So, you know, use your own judgment. I'm not going to sit there and, you know, Blackboard's not going to give me some sort of warning that he went away from the web page and, you know, that kind of stuff. So, hey, I mean, if you want to Google everything, I mean, that's on you. I don't care. I'm strongly encouraging you not to do that because you won't learn. Okay, so definitely be able to create variables, understand the concept of variable resolution. So when you have a variable name, it's kind of like a placeholder, and at runtime, it'll turn into the value that guy holds. Be able to work with conditionals, so if statements with our Boolean expressions. Understand the if, the else, the elif. We've used the elif several times for the else if. So be able to work with those. Be able to work with for loops. Understand specifically how that range guy works. So know its starting value, including, ending value, not inclusive, and then the step, if we give it that third parameter. So know how that works. You know, it'd be fair game for, you know, me to ask you to write something that does something backwards, or me to give you some code and say, what does this do? And it relies on you understanding that I can have a range go from 10 down to 1 by steps of 2. That kind of stuff. Okay? Be able to work with while loops. The concept of pre-check loops versus post-check loops. For loops and while loops are both pre-check loops, but we really haven't seen the alternative. So I'm not going to ask you something specific about this concept because you don't really have all the context you need. Punchline is pre-check loops ask the question before they ever execute the body of the loop. Where post-check loops don't. They execute the body once, then ask the question. All right, but I won't ask you anything specific about pre-check loops on this exam. You should definitely be able to run a Python program, but I'm not going to necessarily test you on that. I won't say like, write the command to change directories into such and such and then execute a program called test.py at the command line. I expect you to be able to do that because you've been doing your homework up to this point, but I'm not testing you over that. That's not a skill that has to do with your programming ability. That's a skill that has to do with your ability to use your computer, right? Same thing with the tools we're using. I'm not asking you anything about Atom or the terminal or any of that stuff. You should be getting good at those things, but I'm not going to test you on it. Definitely be familiar with our couple of tools that we've introduced. So converting the value in a variable to an int, converting the value in a variable to a string. Know what those guys do, know when you need them, that kind of stuff. I'll throw out there again, I said it earlier today, but that idea of concatenation, if we're using the plus sign, it's the concatenation operator if both sides of it are strings. It's the addition operator if both sides are numbers. So if you want to glue a couple of strings together, so you have like hello and then the number 5, you're going to have to turn that number 5 into the string 5 to glue those guys together. Okay, they can't be different types. Okay, remember I've mentioned that a couple of times today already. Important that you understand that that plus sign is concatenation operator if both sides are strings, it's addition operator if both sides are numbers, and it's an error if they're different types. Don't forget about the CS Hackathon. That would be a great question. What's the date of the CS Hackathon? If you haven't already marked your calendar for this guy, make sure you mark your calendar for this guy. Like I said, it's required for my classes, and the homework assignment is crazy. Go ahead.
Is there anything we need to do for that other than emailing Professor Locklear?
Nope. Nope. As we get closer to it, I'll release teams. Then you'll probably meet with your team maybe once or something, or at least have chats with them on Slack, but nothing to prepare or anything like that. Be able to work with strings heavily. I do like, just as a general rule, I like string manipulation type questions. I like list manipulation type questions, even though we have not introduced lists in class. So there won't be any programming questions dealing with lists, even though you've already seen them quite a bit in the book. I promise you we'll be using lists a lot very soon, but we just haven't worked with them in class because we've been doing most of our stuff related to strings. So be able to work with strings and go through and remove stuff from them or add stuff to them or convert things in them and all sorts of stuff. Be able to do string concatenation. Here's our string converter dealy flippy thingy. Know how strings are represented, at least from the perspective of a string has a length. We can use our length function, len, to tell me how many characters are in a string, and the legal buckets are 0 to the length minus 1. So understand how under the hood strings are represented and how you can get at individual characters in the string and that kind of stuff. All right, so this is like I introduced this for each loop, so you can technically go through like a string and say for C in S, let's say S is hello. Each time through, C will be the next letter in my string. It'll be an H, then it'll be an E, then it'll be an L, then it'll be an L, then it'll be an O. But I don't have access to what bucket I'm looking at. So if I want to use a for each loop to go through every element in my string, that's fine. I can write something like this. I'll just go over to Atom real quick. Just write it here at the bottom. Here, I'll just do it with my expression here. So if I say for C in expression, print C, expression is this string right here. So each time through, whatever variable I put there will be equal to the next guy. So the first time through, C will be equal to the character 1. Then it'll be equal to the character 2. Then it'll be equal to the character 3. Then a minus. Then a 5. But I won't have access to, I'm at bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So I won't know where I am in the string. I'll just have access to each individual element. So if you're going to use a for each loop, use it for the proper reason. The one thing you could say is you never actually have to use a for each loop. You can choose to just go ahead and say for I in range 0 to length of expression, print expression at bucket I. Those two for loops do the same thing. This guy just lets you conveniently get at the character if that's all you really needed. This guy says, look, I know where I am in the string because I'm taking an I on a voyage between 0 and the length of expression minus 1. And each time through, I will extract the character at bucket I in the string and print it out. Output of these guys will be the same. The difference is down here, I can get the character, but I also know where in the string I am. Okay, I probably would not directly ask you to write a for each loop because we haven't done too much practice with them, but it would be fair game if I showed you some code that had a for each loop in it that you should know what it did. Okay? Well, I'm calling this a for each loop. Yeah, so for this value in each element of this expression. Know how range works. Important concept. We use that guy a lot. So be able to see that and interpret it. Be able to write functions. These reusable chunks of code we've been using a lot lately. So if I say write a function that takes some parameters and does something and returns the answer or prints something, be able to write that type of thing. You will, if I ask for a function and you just write me some code with no function attached, you're going to lose points. Okay. I want you to show me that you know what a function is to start with. Okay, don't just write random code, put it inside of a function if I ask for a function. Another tip is it's never going to be the right answer on a programming, let's say programming anything, if you are hard coding the answer for a very specific solution. So if on the exam I give you an example, if I say, for example, if the input was this, the output should be this, your function should work for all legal examples, not just the one I gave you. Okay? I just happened to give you an example so you have a sample of what it would do if you had passed your function those parameters. So if you find yourself hard coding stuff that I put in an example on the exam, it's probably going to be wrong. Okay? I want you to write code so that it works on generic inputs. If I ask you to write a function that adds two numbers together, and then I say, for example, if the two numbers was 2 and 3, it should return a 5. I don't want you to just say int a, or say a equals 2, b equals 5, return 2 plus 5, or return a plus b, and say that's good. I want you to write the function so that it takes in an a and a b and returns a plus b. So it'll work for any two numbers I give you. Okay? Understand the difference between return and displaying. If I ask you to have a function that returns a value, you're going to be doing some sort of magic inside the function, ultimately spitting out the answer with a return that you could then choose to display later on. As opposed to if I say write a function that displays all the values between 1 and 10, that guy doesn't have to return anything. He'll just print a bunch of stuff. Okay, but there is a difference between returning a value internally in your program that you can do whatever you want with later, including print, and printing a value or displaying a value. I probably won't directly ask any questions dealing with scoping rules. This really has to do with where variables are accessible in your program. This will become much more important in the second half of the semester when we start writing our own objects and we kind of have more of our program kind of spread out. Right now we just kind of have like kind of chunks in different places, so I won't ask you anything about scoping rules, and I won't try to trick you with code dealing with a scope of a variable where it's accessible or that kind of stuff. Be familiar with the find tool. Specifically, how important this -1 piece is. We've used that quite a few times already. That's really the most important part of find. I mean, it's great that it helps you locate something that you do have, but it's really great that it'll tell you if something's not there. Okay, so that -1 says I couldn't find it. That could be pretty helpful. Okay, and this is really an example of what I talked about earlier. With primitive types, they can only hold a value, whereas object types could hold a value and potentially do more. So here's my string. So I have a variable called s. Pretend this is lowercase because it just capitalized it for me. So this guy holds a string hello, and then I say s.find. So I'm using my string to find another value in it. So this guy's doing more than just holding a value. He has this special function called find that's part of what strings know how to do. Okay, so these guys are objects, and we're going to see a lot more examples of that in the second half of the semester. But you know, I'm giving you that as kind of a high-level thing here, difference between primitive types and objects, even though I'm not going to ask you about that on the exam this time. It'll definitely be represented on the final. Okay, but that's going to become a lot clearer moving forward. Okay, so that's all of our slides. So what questions do you have for me? Anything you want me to review or go over? Go ahead.
So this is closed book test, right?
Correct. Closed book, you can use your calculator. You can use your phone if that's where your calculator is. Don't use Google. Don't use the buddy system. All that stuff. But the one thing I'll throw out there is the exam is not going to focus heavily on memorization. So, for instance, you should know the thing like how do human beings solve problems, memory, asking questions, repetition. We've said that enough times that that's kind of one of those things. But I'm not going to ask you to regurgitate some chunk of text that I have on some slide. Okay, I want you to show me that you can apply the things you've learned in here as opposed to that you spent 10 hours studying for an exam and committed everything to memory. Because that's just because you know something like that doesn't mean you can do it. And when you go out to industry, you're going to have a nice little reference book next to you for reminding yourself of something, and then you need to be able to do it. So most of the questions I'm going to ask are much more about applied type things or proving to me that you understand a concept as opposed to that you memorize the exact verbiage that I used. Go ahead.
But it is okay to use Atom to just like write out.
Yeah. If you want to use Atom for typing and, because maybe the little text box that Blackboard gives you kind of acts funky or something, that's fine. I don't care. Whatever you need to do to give me the best results that you can. I think you might be able to upload a picture as part of your solution to a question on Blackboard. I'm not 100% positive, but if you wanted to do the conversion question by hand, for example, and then take a picture of it with your phone and email it to yourself, and then open up the web browser to grab your email to upload that picture, if that's the way you think would be easiest for you to do it, that's fine. Like I said, use your best judgment. If it's not cheating, it's probably not cheating, right? But if you think it's shady, it's probably shady. All right, but if you want to attach a picture or something, I'm fine with that. All right, what other questions? Any code example you want me to review? While he's looking it up, I'll just remind you again, remember, we're not in class on Friday. You're taking this on Blackboard, but it's only available during the class period. And I will try to get it graded actually later that day. You won't have to wait till over break. I'm going to have some time waiting at airports and stuff like that. The worst cases will be graded like later that night or the next day or something. But timing-wise, I should be sitting at an airport for a chunk of the time after the exam is done that I should be able to get some of it graded or something. But you'll get it back way before the end of break is the punchline. So what examples do you want me to go through? Go ahead.
I was going to say kind of an example, kind of like a reverse string, reversing a string.
Okay, so like I asked you to write a function called reverse string that took a string as a parameter, something like this. Okay, I'm probably going to build a brand new string. So strings we can't change in line. I got to build a new one. So I'll probably say something like answer, start that guy off as the empty string. Then I'm going to walk my input string backwards. So for I in range, the last legal bucket of S is length of S minus 1. All the way up to, but not including, well, I wanted to include bucket 0, so I have to say all the way up, all the way down to, but not including -1. And then I want to take steps of size -1 to walk backwards. And then I'll say answer is equal to answer concatenated with S at bucket I. Then I'll return answer. So this is an example where here's a function, takes a string as a parameter. I'm going to build a new string. I'm going to walk through my original string in reverse. That's what that for loop does. Each time through, I'll tack on the current character I'm looking at in my string that was passed in onto my answer as I'm building up that string. And in the end, I'm going to return that answer. I'm not printing it. I'm returning it to whoever called this guy. So somebody else later on is going to say blah is equal to reverse string of hello. And then he can choose to then go and print blah if he wanted to, print that variable, which would be hello in reverse. But he doesn't have to. This guy returns an answer, and I'm going to, so this will boil down to the string in reverse. I'm going to store it here in this example. Anything else you want me to? Any other code examples? Go ahead.
What's that thing where you can, instead of printing to the next line, it prints on the same line?
So if I wanted to, well, it's this. So I can say, here, we're going to say for I in range of 0 to 10. Let's go through 0 to 9. And what I'll do is instead of having it, I'm going to, if I just said print I, this will print 0, 1, 2, 3, all next to each other. But if I want to have them printed next to each other, I can go ahead and say print I, comma, end is equal to the empty string. And that will print them right next to each other. So I'm replacing, so by default, end is this guy. It kicks it down the line by default. So by me saying I want end to be the empty string, or I can say end is the space if I'd rather have it like that, I'm saying print, put this at the end of the line, which will not kick it down the line. That make sense? And that's probably not something I would ask you to write. It's possible if I gave you a code example and said, what does this do? I would, you should be able to read that. One little caveat, when I give you code examples and I ask you what this does, I mean, you can do this, you can tell me what each individual line does, but what I'm really asking you to tell me is, as a whole, what does this code accomplish? Okay, so for instance, if the code displays a string in reverse, if that's ultimately what it does, tell me this program will take a string as a parameter and display that string in reverse. Don't tell me that it has a for loop that goes from 0 to the length of the string. Each time through, it adds something to a new string. And then in the end, it displays what's in that string. You haven't told me that you've recognized the code reverses a string. You just told me what each line does, which is fine if you want to tell me that part, but I ultimately want to know what does the code accomplish. Anything else? Go ahead. And we're technically done, so if you want to take off, but I'll answer any questions.
Would it be a good idea to review the past programming assignments for?
I think that'd be a pretty good idea.
Uh-huh.
Yep. Make sure you understand everything we've done up to this point.
Okay.
All right. I will see all of you, hopefully most of you, in the Monday after break. But make sure you take the exam during class this Friday. All right?